So picture this. You are sitting in a massive, high-stakes strategy meeting.
Oh, we've all been there. The tension is just thick.
Right. The pressure to innovate is just completely suffocating the room. And inevitably, someone leans forward and says, well, let's just route the entire workflow through Claude.
Yeah, or, let's just build it all on top of ChatGPT.
Exactly. It is the ultimate temptation right now. It feels like throwing this massive, brilliant safety blanket over whatever business problem you're trying to solve.
It really does. It's the path of least resistance in this current AI boom.
But architecturally, it is the equivalent of using a 10-pound sledgehammer to type on a keyboard.
That is a great way to put it.
You default to the biggest, smartest, most resource-heavy artificial intelligence model available, and you just sort of assume raw technological power will magically take care of the rest.
Right, because you look at these massive trillion parameter models and you see their staggering reasoning capabilities.
Yeah.
So you naturally think, why on earth would I architect anything else? I'll just plug into the smartest API and my product is instantly future-proofed.
Except the entire tech industry might actually be walking into a massive architectural dead end.
Yep.
And they're doing it purely because it feels safe. So, welcome to the deep dive. Today, we are unpacking a truly fascinating thought leadership piece from July 2026.
It's a fantastic read.
It really is. It was written by Krishna Raja. He's the founder and CEO of a company called Support Logic. And he penned this article titled, LLM Commoditization, Why Just Use Claude is a Mistake.
And what he does so well here is he takes the frantic, unpredictable, just totally overwhelming AI market of today, and he maps it directly against a 50-year history of the database industry.
Yeah, the parallels are wild.
The central thesis is that these two timelines rhyme perfectly. Like if we look closely at how the great database wars of the past few decades ended, it provides a perfect roadmap for exactly where AI is going.
And the most sobering lesson from that entire history is that the underlying technology itself, like the raw computational engine, that will absolutely not be your moat.
No, not at all.
Okay, let's unpack this. Because to understand why relying on a massive frontier model is a trap today, we really have to rewind the clock to the 1970s and 1980s.
Back to the genesis of the database.
Right. Before Edgar Code published his relational model, just retrieving data from a mainframe was like this bespoke, agonizing engineering project.
It was incredibly manual. You had to physically understand exactly where the data lived on a hard disk just to get it out.
Wow.
Yeah. Code's relational model changed the world because it turned data retrieval into a declarative question.
So instead of writing complex procedural code to hunt down a customer's address, you just described what you wanted using SQL.
Exactly. The database engine did all the heavy lifting of figuring out how to navigate the tables and the indexes to get it for you. It meant businesses could suddenly interrogate massive volumes of data in seconds instead of, weeks.
Which kicked off the first great wave, right? The era of the engine empire.
Oh, yeah. Oracle, IBM DB2, Sybase, Informix.
These companies built absolute fortresses, and they competed purely on raw, unadulterated engineering physics, like who has the fastest query performance, who can handle the highest transaction volume.
Right. And they used these industry standards called TPC benchmarks.
Yeah.
They were literally stress testing systems to see how many transactions they could process per minute, and they used those numbers as their main marketing weapons.
We are the fastest by us.
Exactly. In that era, the capability of the technology was the entire product. The moat was the engine itself. If your engine could process 1 million rows a millisecond faster than the competition, you won the enterprise contract.
And the parallel to today's frontier AI labs is almost uncanny. Just swap out TPC benchmark for MMLU score.
Yep.
Today, Anthropic, OpenAI, Google DeepMind, Meta, they are all using massive standardized tests as their battlegrounds. Like the MMLU, which tests a model's knowledge across, physics, law, mathematics.
It is an arms race of raw capability.
Yeah.
And it's built on the exact same assumption Oracle had in the 1980s, that the smartest, most powerful engine will inevitably win the entire market.
What's fascinating here is how the sheer brilliance of these frontier models actually lulls companies into a false sense of security.
Oh, completely.
Because the neural networks built by these labs are staggering generational achievements in computer science. But that undeniable excellence tricks software architects into thinking that defaulting to the biggest API is the correct architectural choice for every single workload.
It's the exact same psychological trap from the 90s, when buying an Oracle license was like the famous nobody gets fired for buying IBM equivalent, but for data.
Let me bring in a metaphor here because I think this helps clarify things. Using a massive, multi-trillion parameter frontier model to classify simple customer support tickets is like buying a multi-million-dollar Formula One car.
Just to drive down the street to pick up groceries.
Yes, exactly.
Yeah.
I mean, sure, the car works, it gets you to the store, it feels incredibly safe because the engineering is flawless. But it is completely impractical, wildly expensive to maintain, and honestly, a bit ridiculous when you look at the mundane task you are actually trying to accomplish.
Well, think about it. A Formula One car requires a literal pit crew just to start the engine.
Right.
And when you look at the latency and API costs of a Frontier model, you are paying for a digital pit crew every single time you ask it to summarize a 3-sentence email.
That is so true. So if those massive database engines like Oracle were so incredibly powerful, why didn't they just become the permanent operating system for the entire internet? Oracle is huge, but it didn't swallow the whole world.
Well, that brings us to the underlying business pressures that start the second wave of our historical map.
The internet boom.
Right. By the late 90s and early 2000s, the internet was exploding. But a couple of college kids launching a startup in a dorm room literally could not afford a 6-figure Oracle enterprise license just to host a basic web forum or a blog.
They needed a rebellion.
And that rebellion came in the form of open source databases, specifically MySQL and PostgreSQL.
Now, those open source options were notorious for being slightly less robust in the early days, weren't they?
Oh, absolutely. But they completely took over anyway.
Because they won on form factor, not physics.
This is a crucial distinction. The relational physics of MySQL were identical to Oracle. At a high level, they did the exact same thing. They had tables, they used SQL, they managed relationships between data points.
So MySQL didn't out-engineer Oracle on raw speed or complexity?
Not at all. They won because they were free, lightweight, and could run on cheap commodity hardware. They became the M in the legendary LMP, Stack, Linux, Apache, MySQL, PHP, which completely democratized web development.
MySQL was good enough for read-heavy web workloads, and its accessible form factor mattered infinitely more than Oracle's raw power.
Which leads us directly to the open-weight AI model ecosystem of today.
Right. Models like Llama from Meta, Mistral, Qwen, DeepSeek.
Exactly. Just like MySQL in the early 2000s, the underlying physics are shared with the enterprise giants. These open models predict tokens, follow instructions, and write code just like the closed frontier models do.
But the form factor changes everything.
It really does. You can take an open-weight model and fine-tune it on your own hardware. You can run it locally in an air-gapped server room for, say, strict healthcare privacy compliance.
Or you can compress it and run it directly on a smartphone.
Precisely.
Okay, wait. I need to jump in here and play devil's advocate for a second, because the database parallel feels a little strained to me on this specific point.
How so?
Well, in 2004, MySQL and Oracle were essentially pulling the exact same data. Oracle just did it faster or with more security. But today, frontier AI models are demonstrably mathematically smarter than the open-weight models.
That's true.
So if a company has massive funding, why would they ever settle for a good enough open model? Like, if you can afford the absolute best intelligence available, why wouldn't you buy the Formula One car?
Because it comes down to understanding that capability is strictly workload relative.
Workload relative. Okay, explain that.
The value proposition shifts from raw, overarching capability to finding the perfect fit. Think about a developer in 2004 launching a basic message board. The extra enterprise-grade transactional power of Oracle was entirely useless to them. It was just expensive overhead.
Sure.
Today, if your specific workload is analyzing the sentiment of a customer chat like, is this user happy or angry, the deep reasoning capabilities of a frontier model are completely wasted.
Oh, I see.
You do not need an AI capable of passing a unified bar exam just to figure out that a customer is furious about a delayed package.
You just need a model that executes that specific categorization with zero latency, high reliability, and a fraction of a cent in cost.
Precisely. The quote-unquote smartest model is actually the dumbest choice if the latency ruins the user experience.
Okay, that makes sense. But there is a massive elephant in the room when we try to cleanly compare databases to artificial intelligence.
Ah, yes. The hallucination problem.
Yes. I mean, open source databases like PostgreSQL might have been cheaper and lighter, but they were still mathematically exact. If you query a database for a user's phone number, you get a deterministic answer.
Right.
AI models are fundamentally probabilistic. They are guessing the next word. And sometimes they hallucinate completely fake information, confidently citing legal precedents that do not even exist. So how on earth can you argue that a technology prone to hallucinating facts fits into a clean historical parallel with exact relational databases?
It's a great question. You have to look at the third wave of data infrastructure, the big data and NoSQL era, because databases actually stopped being mathematically perfect on purpose.
Wait, on?
Yes. As web-scale applications like Facebook and Twitter exploded, they needed to scale horizontally. You couldn't just buy one giant mathematically perfect server to handle 1 billion users.
Right, you'd have to spread the data across hundreds of cheap commodity servers.
Exactly. But in computer science, there is a foundational rule called the CAP theorem. In a distributed data store, you have to make a choice. You cannot mathematically guarantee perfect consistency, perfect availability, and perfect partition tolerance all at the same time.
Something has to give.
Something has to give. So a new generation of architects building systems like MongoDB and Cassandra made a choice that would have been absolute heresy to an Oracle engineer a decade earlier.
What did they do?
They deliberately traded away strict, mathematically perfect accuracy, which are known as ACID guarantees, in favor of a concept called eventual consistency.
Okay, here's where it gets really interesting. So you're saying that returning stale or slightly inaccurate data wasn't a glitch in these NoSQL databases. It was a deliberate engineering compromise to survive massive scale.
It was a highly calculated trade-off. Architects realized that their specific applications, like loading your social media feed, didn't need to be perfectly mathematically exact, down to the microsecond.
Right. If you see a post 5 seconds later than someone in another country, no one dies.
Exactly. The system just needed to be incredibly fast and always available. And this maps flawlessly to the probabilistic nature of large language models.
Wow. So an AI model hallucinating or guessing is just the eventual consistency of this new era.
Yes. For certain workloads, say calculating payroll or strict medical dosing, a hallucination is obviously unacceptable. But for brainstorming marketing copy, or extracting overarching themes from a massive dump of unstructured survey data.
Or drafting a polite email response.
Right. A probabilistic guess is a perfectly rational trade-off in those cases. Demanding deterministic, perfect accuracy from an LLM for absolutely every single task is as foolish as demanding a strict two-phase commit transaction just to update a user's profile picture.
For those who don't know, a two-phase commit is where an entire network of databases locks down until every single node agrees on a data change, right?
Yes, you are demanding a level of strict mathematical rigor that the specific workload simply doesn't require, and you are paying a massive, crippling penalty in cost and speed to get it.
Which logically means the tech industry is not heading toward a monolithic future. We are not going to be dominated by one giant generalized AI that does everything perfectly.
Not at all. Which brings us to the fourth wave in our historical map, specialization.
The Cambrian explosion.
Yep. As the NoSQL era matured, we didn't just get one super database to replace the relational ones. We got dozens of highly specific engines built for isolated problems.
Like time series databases.
Right, like InfluxDB, explicitly designed to ingest millions of high-speed telemetry data points per second from IoT devices.
Yeah.
And we got graph databases like Neo4j, designed purely to map complex relationships like fraud rings or social networks.
They didn't win by being generally better at everything. They won by being completely untouchable in their specific niche.
Exactly. If you try to store a company's complex financial billing records in a time series database, it would be an absolute disaster. But if you use a relational database to track high-speed server telemetry, the system just crashes.
And that is exactly what is happening in AI right now. We are entering the era of massive specialization. We are seeing the rise of small language models, or SLMs, that run entirely on a device to guarantee zero latency and absolute privacy.
We are seeing hypervertical models fine-tuned exclusively for complex legal reasoning, ignoring everything else.
We're even seeing tiny specialized models whose only job is agentic tool use, like simply knowing how to navigate a computer's user interface and click buttons without needing to know any trivia or history.
But alongside this flourishing of new specialized models, our source article points out something very cautionary. A technological funeral.
Oh, the funeral of Hadoop. I remember the Hadoop era. It felt like everyone in tech was absolutely convinced it was the inevitable future of data.
A little over a decade ago, Hadoop had massive multi-billion-dollar valuations and its own entire conference circuit.
Because data was getting too heavy to move over the network, right?
Right. So the core premise was Hadoop allowed you to bring the compute power directly to the data, spreading it across massive, local clusters of physical hardware. Companies spent millions hiring Hadoop specialists and building these intricate local data lakes.
But then Amazon Web Services and the public cloud took over.
Exactly. Object storage, like Amazon S3, became dirt cheap, and the cloud provided elastic compute power on demand. Suddenly, the entire foundational premise of Hadoop just vanished overnight.
The technology itself didn't fail. The engineers didn't do a bad job. But the physical constraint the technology was built to solve was entirely eradicated by the cloud.
Yes.
So let me ask a really pointed question based on that. Look around the AI ecosystem today. Are companies currently building billion-dollar bridges to nowhere by overinvesting in AI workarounds?
If we connect this to the bigger picture, absolutely. Look at the massive ecosystems of AI tooling being heavily funded right now. You have intricate prompt engineering chains designed purely to bypass the context limits of current models.
Or incredibly complex orchestration tools designed solely to manage the temporary scarcity of GPUs, like throttling requests so systems don't crash.
Those tools are the Hadoop of the AI cycle.
Because the moment the underlying constraint disappears, the tool is useless.
Exactly. When GPU scarcity inevitably vanishes in a year or two as silicon supply chains catch up, or when model context windows become functionally infinite, which we are already seeing glimpses of, all of that billion-dollar infrastructure built around those limitations becomes completely obsolete.
Okay, so if the massive frontier engines like Claude and ChatGPT are destined to become interchangeable commodities, and the temporary workaround infrastructure is going to go extinct, like Hadoop, who actually wins? Where does the money flow?
We just have to look at who ultimately won the data wars. It wasn't the companies building the absolute fastest query engines. The big winners were platforms like Snowflake and Databricks.
Ah, when you frame it that way, their trajectory makes perfect sense. They didn't win by bragging about engine physics. The query engine was already commoditized by open source.
Right. Snowflake won by solving all the painful problems around the engine.
They solved workflow, governance, data sharing, security. They didn't sell an engine, they sold an outcome. The query engine just became a hidden implementation detail underneath an elegant interface.
The value completely migrated up the stack. It left the raw engine layer and pulled in the workflow and service layer.
And the source for this deep dive, Krishnaraj Raja, explains how his company, Support Logic, is explicitly building for this exact reality in the customer experience, or CX, space.
Yeah. Instead of waiting for AI to commoditize, they are architecting their platform with the assumption that the engine is already a commodity.
They've built what they call a cognitive AI cloud. It is a fascinating technical approach because it entirely rejects the just use Claude for everything mindset. They rely heavily on a multi-model orchestration layer.
Let's slow down and explain exactly how that works, because it's important.
Sure. So they aren't placing a bet on one single model. If a customer task comes into their system and it involves simple sentiment scoring or routing a ticket to the right department, their orchestration layer automatically routes that specific task to a small, ultra-fast model.
The priority there is low cost and zero latency.
Right. But if a task requires deep, complex reasoning, like synthesizing a history of 30 emails to draft a technical apology, the system automatically detects that complexity and routes it to a heavy frontier model.
They are dynamically matching the workload to the perfect form factor in real time. Beyond that, they have adopted a CRM-less architecture.
Which sounds completely counterintuitive for a customer experience company.
Yeah, it does. But they are treating the traditional customer relationship management system, like Salesforce or Zendesk, the way modern data stacks treat a single database. It's no longer the monolithic center of gravity. It is just one node, one source of truth among many.
Because by decoupling the intelligence from the CRM, you avoid the ultimate trap vendor lock-in.
Exactly. The CRM just holds the records. The AI layer sits above it, reading and writing to it, which means a company can swap out their CRM without breaking their entire AI workflow.
And the final piece they use to tie all this together is an MCP server. For those who aren't familiar, MCP stands for Model Context Protocol. Think of it like a universal USB-C standard for AI.
It's a great analogy.
Instead of writing custom, brittle API integrations for every single new AI model that hits the market, an MCP server acts as a universal translator. You plug any AI agent into the MCP server, and it instantly knows how to read your local systems, your data, and your workflows securely.
And Support Logic is using this to expose their intelligence to any model the client chooses to use. Open interfaces, multi-model routing, They're entirely focused on selling the workflow and the business outcome, while treating the underlying AI engine as an interchangeable commodity.
So what does this all mean for you listening right now? If you are sitting in that strategy meeting we talked about at the start, facing a massive build versus buy dilemma for AI in your own company, this is the historical trap you must avoid.
Yep. If you build your own internal tooling and wire it exclusively to a single frontier API, say hard-coding your entire company workflow on OpenAI or Anthropic, you inherit their entire cost curve.
You inherit their network latency, you inherit their rate limits, you are completely at the mercy of their infrastructure.
And you inherit all of that heavy baggage for mundane workloads that never needed frontier-level reasoning in the first place.
You are essentially choosing to install a multi-million-dollar Oracle Enterprise database just to run a simple internal to-do list application. Multi-model orchestration isn't some neat feature you can just bolt on later when things get expensive. It is the fundamental architecture you have to start with today.
This raises an important question about the role of the modern tech architect. Because historically, when a foundational technology commoditizes, people panic. They tend to think the field is getting boring, or that their skills are no longer valuable.
We hear it all the time now. The AI does all the coding, so human software architects are obsolete.
But look at history. Database commoditization wasn't boring. It was incredibly liberating. The fact that developers didn't have to worry about writing raw data retrieval physics is exactly what made the modern massive cloud data stack possible.
So for AI, commoditization means the architect's job is no longer about worshiping a single engine or, writing clever prompts to squeeze performance out of one model.
The job is now about composing systems. You have this rich, sprawling, interchangeable palette of models, small ones, fast ones, hyper-specialized ones, frontier ones, and your job as an architect is to creatively orchestrate them to solve actual human problems.
So here is the absolute core takeaway from this deep dive. The underlying technology itself, the neural network, the transformer architecture, the massive LLM, is never going to be your durable moat. History proves this.
Value always migrates up the stack. It pulls around the workflow and the problem, not the engine.
Your strategy has to be matching the right engine to the specific workload, not just blindly throwing your data at whatever model happens to be at the top of the benchmarks this week.
The engine is just an implementation detail. The answer, the outcome, is the entire point.
Which leaves us with one final provocative thought. If artificial reasoning is rapidly becoming a cheap, interchangeable commodity, if the actual thinking part of the software is basically free, does the job of the tech architect actually become much less about understanding code and entirely about understanding human psychology and business strategy? If you no longer have to worry about how the F1 car is engineered, maybe your only real job left is finally figuring out exactly where the customer actually wants to go. Thank you for joining us on this deep dive. Take a hard, critical look at your own AI strategies, and we'll see you next time.